Okay, so I want to show stack diffs off in practice, and I wanted to use a minimal example to sort of illustrate the points. So I've got this little play repo here with just one file. This is an empty text file, and it's already been committed to the repo as our initial commit. So you can see Git in it. And what we're going to do is simulate a stack diff workflow. We'll create 3 branches: stack A, stack B, stack C. Stack A is the top of the stack, stack B right below that, stack C under that. To simulate sort of, stack A is our sort of initial foundational logic. Stack B works to add some additional logic on top of stack A. It includes everything from stack A with some additional logic for that layer, and then so on and so forth. Stack C does the same. It includes things from A and B, and has stuff specific for C. And you can go on and on, but we'll stop at C just to illustrate the point we want to make. So the first thing I want to do is create our initial branch. So this is like sort of the first foundational logic we're going to create. And we're going to use this text file that I talked about, this empty text file, to simulate code changes. We don't really care about the specific code changes, but each time we make a commit, we'll add some text to that file just to make it clear that there's some code change that happened. And this will actually end up being a nice example in terms of how rebases work and how to deal with conflicts and sort of the different nuances that come up with the stack diff workflow. So we're on stack A. Let's make some changes. So this is the first change from stack A. We'll commit it. Amazing, right? So stack A, we have a commit in stack A. But let's say now we want to start work on the second piece of our feature, right? We'll call this stack B, right? This will be the name of the second branch. So if we do a git log, right, you see we have the first commit from stack A, and then when we go to make our change, we have that line from stack A. Let's add a second line for this change from stack B. This is the first change from stack B. Git log, we haven't done anything yet. Let's commit it from stack B. Great, we have our new commit. And then let's go one layer deeper now, sort of the next layer of our feature work into stack C. Again, we're going to edit the file, be a little more efficient this time, and just do a copy paste. Commit it. Nope. Git commit stack C. Okay. So we're on branch stack C right now, right? And you can see stack C's git log includes, the first commit from stack C. It also includes the commit from stack B. It also includes the commit from stack A. Great. So this is sort of the basic stack diff workflow. Now let's introduce something that is going to be pretty typical in a stack diff workflow where a change happens upstream. So let's say in stack A now we either get some feedback, PR comments, some feedback on our changes, right? And we want to make some changes, or we even, everything's good and we merge to main. It's essentially going to work out the same way in terms of what this rebase will ultimately look like, but I'm going to simulate it with a adding an additional commit to stack A, just to show off also how to deal with merge conflicts. But it will essentially be the same idea if you were merging straight into main. So git checkout. Let's go back to A, and we're going to make a new change, right? So edit this file. Edited, right? So I just want to add that, add output. And this is going to be our second commit from stack A, right? And then we're on stack A, so we have that. So we made this change in stack A, but now let's go to stack B, right? Which obviously its head was previously pointing at the tip of the stack A branch. So let's go to stack B. One thing I'm going to call out here, right, is you see Git is very branch centric. Everything we do is based on sort of what commits are in the branch that we're looking at. There's some tweaks you can make to the commands you're calling to kind of expand that horizon a little bit, but this is the standard Git workflow. It's very branch centric. And you can see how that sort of rubs against the grain of how like stack diffs actually work and how we as developers and engineers working on complex features like actually like to work, right? Like we need to maintain our momentum. We can't just like sit around waiting for sequential changes. We want to sort of keep working on all the features and sort of build on changes as we collect feedback. So in this case, right, like I have to keep switching between branches to see what commits are actually there. It's pretty simple because we're using very small commits and very simple messages, which everyone should be doing in general. But this is just like a play example to show, if we had a much more complicated history, it would be annoying to have to switch between branches in order to like make our stack diff workflow really work for us, right? So we're on stack B. This is the git log for stack B. So we have the first commit from stack B, and then its parent is this first commit from stack A, right? But we just made a change from stack A, and we want that reflected now in stack B, right? So our foundational logic has changed. We want that reflected in stack B as well as in stack C. So what we'll need to do is recursively rebase sort of each layer of the stack until all those changes from stack A are propagated down the chain. So the way we do that is with a rebase. So we're on stack B and we want to rebase against stack A, right? And then we have a conflict. Let's deal with that conflict, right? It gives us this output. I'm just going to deal with this manually. I don't want new lines, right? And this was the line essentially that I had created in my second edited commit for stack A. So we'll do that. We're resolving this. Rebase, continue. Yep, that commit is fine. Amazing. First commit from stack B. Now we also have the changes from the second commit from stack A, right? And we still have the first commit from stack A. So if I just look at output.txt, I have this is the first change from stack A, and I have this is the first change from stack B, right? And I have this edited portion that I added with that second commit from stack A. Okay, stack B is up to date. What's a little annoying with this workflow is now I also, like I said, you need to recursively rebase down the stack, down the chain. So I need to do the same thing for stack C. So let's go do that. Let me go to stack C, and I need to rebase. Before I do that, let me just illustrate. So I'm on stack C. This is the log for stack C. I have the first commit from C, a first commit from B, and then first commit from A. What's missing is something between the first commit from B and A, which is the second commit from A, right? But to do that, that is now included in stack B because I already rebased stack B, so I need to rebase stack C now. Stack C against stack B. So do that. I have a conflict, right? So I have to deal with that conflict. Let's do it. We'll do this again. Get out of here, get out of here. And you can see the shape of this conflict actually looks a lot like what we just dealt with when we did this in stack, when we dealt with this conflict while rebasing stack B, right? So it is a little bit annoying, but this is sort of like a classic gotcha in working with stack diffs. And it's also why Git is not like an amazing tool for this. There's other things out there, which I'll get into in a little bit. But yeah, this is kind of what you have to deal with a little bit in order to maintain that momentum of continuing to do feature work and development work while you're simultaneously getting feedback and incorporating that back into your changes. And rebase is just like a really good skill for every engineer to know and sort of understand. The Git history itself, you should also think of as documentation. So the cleaner we can keep that, the more linear we can keep that, the better. So yeah, I want to get rid of this. Yep. No new line. Add it. Rebase, continue. Let's see it. All right, so I'm on stack C, first commit from stack C, first commit from stack B, second commit from stack A, first commit from stack A. Looks good. Let's check it out, right? So this is the first change from stack A. This is the edited, so the second commit on stack A. The first commit from stack B, and then the first commit from stack C. right? So we had to rebase, essentially do the same rebase twice. And then you can imagine how annoying that gets, right? If you have to do it sort of down the chain, if you have a bunch of sort of nested changes. But what I want to show next is kind of a simpler flow. And I want to introduce a tool called Jujutsu, also known as JJ, which is sort of a Git alternative, but it's interoperable with Git, which is really nice. So it drops into your workflows, which I'll illustrate here. And it makes working with stack diffs a lot simpler and a lot cleaner. And I'll try to show how that works. So let's just go back to main here. And I'm going to do this JJ git init command. I already have JJ installed. And JJ has this notion. So Git, I mentioned, is very branch centric. Branches are sort of a primitive within Git. JJ doesn't use branches, they use bookmarks. And the reason they call them bookmarks is just because of the way the commit history is sort of viewed within the JJ framework. So look at my bookmarks. When I did Git init, it sort of creates bookmarks. So like bookmarks are just like JJ primitives, and it's essentially going to mirror like the branches that I've created on the Git side, right? So I have stack A, stack B, stack C, and as well as main. Let's look at the JJ log. Okay, so you have this init command. So the way JJ history usually works is like you have like a root commit, right? And then that's 000. And you usually have two IDs. You've got this like lowercase lettered ID, and then you have this classic like git SHA, right? The short SHA. The SHA is obviously like the classic Git artifact everyone's familiar with. But this change ID is essentially an additional ID that stays stable through history rewrites and rebases. And the reason that's important is because in JJ, rewriting history is very normal. And I think anytime you're working with a stack diff workflow, rewriting history is just going to be part of the workflow. Anytime you rewrite history, the Git commit SHAs change, right? Because everything is content addressable in Git. And so when that changes, unless you're like your commit messages stay the same or they're really easy to follow, which is not always going to be the case, obviously, it becomes a little bit difficult to like actually follow what happened and like where your changes went, and it becomes easier to like lose work in that way. This is where the change IDs are really nice here. They're essentially stable across those rewrites. So even if I do a rebase and the commit SHA changes, the change ID won't change. Like it's going to stay the same and it's stable, and it sort of lets me track like, oh, this change, second commit from stack A has this change ID. It's always going to have that change ID, no matter how many times I edit it or rebase it. Like every time I do one of those operations, the SHA is going to change, but the change ID won't. So it's a really nice way to keep track of that. The other thing I really like about this log output here is the branching is really clear, right? So I'll start here at the top. This just in JJ is just like the working copy essentially. This is like where the next change I'm gonna make will go, unless I like do something different. But I won't get into like the nuances of like working with JJ specifically, but I just want to sort of explain what you guys are seeing. The more interesting thing I think is this like second branch that sort of juts out to the right here after init. So these are our stack changes, right? So we've got our first commit from A, second commit from A, right? And then you can see the bookmark is at the tip of the stack A branch. And then you have first commit from B, and then the bookmark stack B is there. And then we have the first commit from C, right? So you can see it's like this nice branch. And then eventually if we were to merge it in main, right, it'll merge back into this main line that goes back to the root, which this is a play repo, but that's like our main branch, right? Where we created our init commit, where we added the output file. So let's do the same thing where we add a commit to stack A. And then we'll use JJ this time to help us resolve sort of that recursive rebasing and see like what's better, what's worse, what's different. So git checkout stack A, edited again. That's our code change. Git commit. This will be our third commit from stack B, or stack A, sorry. Let's see it. All right, first commit, second commit, third commit, great. But like I mentioned before, we want now, we have this new commit added to the stack A tip, we want that to sort of parent where stack B's initial change comes from, right? Because stack B needs to depend on the latest stuff from stack A. Stack C needs to depend on the latest stuff from stack B. Let's go back to the JJ log. So we can see we've added this third commit from stack A. So going from the bottom, right, we got first commit from stack A, second commit from stack A, and then we jut off to the right here, this NQK change. This is the first commit from stack B, first commit from stack C. So we created this new commit for stack A, but we haven't rebased it yet in the sense that this change isn't properly reflected as like the parent of first commit from stack B yet. That is essentially the rebase step, right? And we saw this already with the Git like rebasing that we did manually for the second commit from stack A. So let's do that. Like, let's actually do this rebase. The next thing I actually want to call out is for the change IDs as well as the Git commit SHAs, you'll see that like only some of the characters are in color. And that's actually the JJ UI communicating to you that those are like the minimal, that's like the minimal prefix to uniquely identify this change ID or commit, which is really nice, right? Like you need to like do a git log and figure out what the full commit SHA is. You can just look at the log and it's like, oh, B, that's this SHA, right? Or RV, that's this latest change, et cetera, et cetera. And I'll illustrate that in a second. So what we want to do is we want all descendants of this commit of change ID, N is the uniquely identifying prefix, to be parented by RV. So N onto RV. So what I want to do is do this. The destination is RV, N is the source, and so -S is source revision. So that means all revisions at that, as well as its descendants, and then the destination RV. So like that's like what we want to rebase on top of. We do that, and we got some conflicts as we expected, right? So we'll look at JJ log again. So we have our first thing to note, right, is this looks a lot more linear, right? Because we've done our rebase now. So we have init, first commit from stack A, second commit from stack A, third commit from stack A. Now we've got this like empty change. This is like a JJ thing. I'll address that in a second, but we can essentially like get rid of this. But then we have this first commit from stack B, first commit from stack C, and like they both have conflicts. So the first thing I want to do is, I don't think I need this empty commit. So I'm going to get rid of this. So JJ abandon RV. RV is like how I identify that revision. Alrighty. The next thing I want to do is I want to deal with this conflict, right? So let me go to N, and this is going to be the conflict on stack B. Recall when we did the Git change, we had to like rebase on stack B and we had to rebase on stack C. We had to essentially do the same rebase twice. So in this case, let's go to N. I want to edit that revision. I could have just noted it by N, and we get some good output here, right? Working copy is now at this commit, or at this revision, and there's a conflict, right? Parent commit. This is nice. I like that JJ always tells me like where I'm at and what my parent is. And then this is a two-sided conflict, so let's resolve it. JJ has a nice utility called JJ resolve that lets you do this really easily. This is the file I want to edit, and then these are the changes, right? This is what I want to keep, right? I edited again. This one I don't want, so that's okay to get rid of. I don't want this, right? Because this is the old version. And then I wanted the new line, right? So to summarize, this is the correct first line. This is, we're getting rid of the previous first line. I don't want that previous first line, and I want to maintain that new line between the first line and the stack B line. So let's confirm. All right, that has done it, and it's rebase one descendant commits. What does that mean, huh? Let's see. Now we go back to JJ log, and you see there's no more question marks or red. Everything is sort of resolved, it seems, or everything is sort of fixed, right? How is that possible? Let's go back to stack B. We'll check out stack B. One nuance of JJ is like you have like the changes queued, but then you need to essentially create a new sort of new working copy to like have that change committed. So like I'm just going to do that on top of stack B. Yeah. So this is the new working copy. It's on top of the first commit from stack B, right? Which is fine. We're not going to add anything else to stack B for now. But then on stack C, right, we branch off to the right. And it looks like there's no conflicts, but let's confirm everything. Let's go to stack B. Stack B. And now I'm looking at the Git log because this is probably what folks are a little more familiar with. So I have this first commit from stack B, which is parented by the third commit from stack A. That was the new commit I added. Second commit from stack A, first commit from stack A. That all makes sense. Let's look at the output. Yep, those are the two lines, right? I added this edited again, and then this is the first change from stack B. Looks good. Let's go check out stack C though. What was interesting was when we did the entirely Git-based workflow, we had to also rebase stack C, if you guys recall. But in this case, something interesting has happened, right? First commit from stack C is parented by first commit from stack B, which was already parented by the first commit or the third commit from stack A, right? Followed by second commit, followed by first commit. So I didn't need to manually rebase stack C because it's already happened for me somehow. And that's actually the nice thing about JJ is because JJ's history is not branch centric, like you get a single history that sort of cuts across branches, which is where it becomes a really nice tool for dealing with stack diffs, right? Because stack diffs are small atomic commits that are being committed across branches. But now JJ sort of gives you a history that cuts across branches, and you can kind of see how those things interact and sort of they are staying linear, and it's really easy to like maintain them being linear. And the really annoying thing about working with stack diffs with Git, like I mentioned earlier, was you need to recursively rebase, right? And that's dealing with conflicts, et cetera, et cetera. JJ makes rebasing really easy. You're able to do your rebase and then have it applied recursively if there are no conflicts. So, if it succeeded fine the first time I did that rebase against stack B, it would have propagated all the way down the chain for all the descendants of the stack B commits, right? Which would include stack C, stack D, et cetera, if there were others. So super interesting, very cool. In this case, we did have conflicts, which is why I want to show like this example, like an example with conflicts, is because, whereas with the Git workflow, I had to manually edit stack A a bunch of times, or I had to manually edit and rebase on stack B and stack C, and you can imagine I would have to do it for stack D and E and F, et cetera, et cetera. In this case, I didn't really need to do that. Like I made that change one time, like I did the rebase one time, and it was captured by JJ automatically. I was like, oh, this is the same sort of merge conflict resolution that can be applied recursively downstream. So it sort of does that for me automatically. So in this case, I have my linear history. Everything is cool. And it would work the same if I merge stack A into main, right? Like say that PR gets approved, I merge that into main. Now stack B's parent, isn't just stack A, right? Like it should be like the updated main, right? So you would just rebase stack B onto main. And then if you're using JJ, it'll automatically, whatever merge conflicts you deal with, it'll automatically get propagated recursively to all the other stacks or elements on the chain or stack. But if you were using Git, classic workflow, you probably need to like go down and like deal with conflicts at each chain. So it's a little more annoying, but it does help you maintain your coding streak, which is great. And it does help you sort of focus on smaller atomic commits, like better commit messages. So like don't make a bunch of changes and then have like one commit message that doesn't really capture the essence of the change you're making. So related changes would be grouped together, and then you have a proper separation of concerns, and then it just becomes really easy to say like, oh, this change should follow this change should follow this change, et cetera, et cetera. But yeah, so that's essentially Git stack diffs in a nutshell, using Git and also using JJ. And I will say, like, if the Git workflow like seems a little bit annoying, that's because I'm contrasting it with how easy JJ makes it, which is really the appeal of something like JJ. But at the same time, the Git workflow of like rebasing, that's like a pretty standard workflow. And I think when you're working on like big complex features that need to be broken up across multiple branches, multiple PRs, and you need feedback on each of those components, it doesn't make sense to like sit around and wait, right? Like you can continue to make progress on your code changes while like that feedback is coming in, and then just sort of incorporate that feedback and changes as rebases, like as you go on and keep implementing. But yeah, so that's basically it. Those are stack diffs and a little bit of a taste of JJ.